So we're looking to solve this system of equations, and we're going to do this one by graphing. So what it is, you're trying to find the point on the graph where both of these functions intersect. If you're graphing it, the solution is where the two functions intersect. It's really the point that satisfies both equations. If you plug them back in, if you plug in the x and the y back in, it should satisfy both equations and be true. So we first have to get the equations in slope-intercept form so we can graph them. So I'm going to subtract 2x for this one. Negative y is equal to negative 2x minus 1, and divide by negative 1, and I have y equals positive 2x plus 1. So I'm going to graph this one, and then for the next one, I'll skip to the slope-intercept form, and the slope-intercept form is y equals negative 5 over 2x minus 8. So I'm going to go ahead and graph this first one using the same color. I have my y-intercept. I'm going to label my m and b. My y-intercept is positive 1. My slope is positive 2. So I'm going to rise up 2 over 1, up 2 over 1, and I'll keep doing my points in the other direction as well. Down 2, left 1, down 2, left 1. And so I'll get my ruler and I can draw my line. Try to put as many points as you can on the graph, at least for that first graph, because it does need to be, when you're graphing, it does need to pretty much be perfect. So if you don't put all your points and your line trails off, you're not going to end up getting the right solution. The next one, I'm going to change colors. I'll go ahead and use blue. So here my m is negative 5 over 2. My b is negative 8. So I graph my y-intercept, my b, negative 8. My slope is negative 5 over 2, which would normally be down 5, right 2. That's the negative slope, but I want to go in the other direction. Up 5, 1, 2, 3, 4, 5, left 2. And you, at least for this one, at least get as many points until you hit that first line. I'm going to do one more. 3, 4, 5 over 2, and now I can draw my line. And so I'm going to draw my line, and I'm going to put my arrows on the ends. And so the point where they intersected, which is right here, is my solution. And so that point is, the x value is negative 2, the y value is negative 3. So my solution is negative 2, negative 3. Now to check it, but you can plug them in and it should work for both of them. So I'll do that over here. So as you can see, when I plug them back in, this is the first one. It comes out to negative 4 plus 3, which is equal to negative 1. And this next one, negative 6 plus negative 10, which is equal to negative 16. So it makes both. You can always check the solution to see if it is a solution by plugging them back in. So there are special cases. Typically with system of equations, you have two lines. Where they intersect is the solution. And that would be one solution where they intersect. There are scenarios where you'll get parallel lines. And because the definition of parallel lines is that they will never intersect, then there is no solution for this case. And basically remember, they're parallel if the slopes are the same. So when you're going to graph it and you see the slopes are the same, as long as it's not the same exact line, they're going to be parallel, which means that there's no solution. And then if they end up being the exact same line and you graph one and then you graph the other one and it's right on top of it, then it's infinitely many solutions. I'm not going to work out some of these because we're going to move on. But these are scenarios that could come up when you're graphing them if they're parallel or if it ends up being the exact same line. So you do need to know what to do in that scenario and what to do if that pops up. So Graphing systems of inequalities, very similar. You're kind of combining the systems of equations with graphing inequalities and finding all the solution points. And it's going to be a solution set. So it's going to be a set of points that will satisfy both of these inequalities if you plug them back in. So we're going to start by graphing the lines. My M for the first one is 2. My B is -4. My second one, let me use a different color. We'll use, let's say, I'll use green. My M is -1/2. My B is 3. So when I'm graphing the first one, y-intercept is at 4. Up 2, rise 2, run 1 to the right. Make sure that's a positive slope like it's supposed to be. It is. Rise 2, run 1. And I'm going to put as many points as I can on the graph and keep going through that. You still want to pay attention to your line. Is it dotted or solid? I'm going to go ahead and use my ruler. So in this case, my line is not equal to, so it means it's dotted. And put my arrows. And you remember you could do this 2 different ways. It is in slope-intercept form, so it's greater than. I'm going to shade up from the line. If I plug in 0, 0, 0 is greater than 0 minus 4, and that is true. So I'm shading towards that point, 0, 0. And what I'm going to do here for now is I'm just going to draw a bunch of lines on that side. So these lines represent the shaded part for this first inequality. Okay, and now I'm going to go and graph the second inequality. My y-intercept is 3. 1, 2, 3. My slope is -2, down 1, right 2. It is a negative slope. Down 1, right 2. Up 1, left 2. Up 1, left 2. And I'm going to use my ruler. And this one is a solid line because it is equal to. And from here, it's less than, so I'm going to shade down from this line, and I'm going to put all these lines going this way. So what I want you to understand is that the solution set is all the shaded regions that intersect from both lines. So if you see here where the purple lines are crisscrossing with the green lines, that is my solution set. And so I can go back and erase these other parts, and I don't want to leave those parts on there. You can shade it in, you can leave it. If that's the only thing that's shaded, you can leave it. But you do need to explain somehow what the shaded region is. Which part do you want shaded? Whether you shade it darker, you shade it in color. You can use colored pencils for this. You can shade one of them one color, one of the other. So if you don't erase these lines, you can also shade it darker, and you can write an S in the portion of the graph that you want to be the solution set. And that implies that you're telling me that that's the solution set. But you have to distinguish somehow. Okay, so we're going to do 2 more. This example is y is greater than or equal to x plus 5. So my m is 1. My b is 5. So when I go to graph that, I'm going to put the y-intercept at 5, and then slope of 1, positive 1, up 1, right 1, up 1, right 1, down 1, left 1, and keep going. And then I'm going to get my ruler. So before I draw it, pay attention, is it solid or dotted? In this case, it's equal to, so it's solid. And I'm going to draw my arrows. And it's in slope-intercept form. So my greater than makes it shade up. And then I'm going to get a different color. We'll say purple again to draw the next one. M is equal to 1. B is equal to -4. So when I graph my y-intercept at B, slope 1 over 1, down 1, left 1, and grab my ruler. Pay attention, is it solid or dotted? This one is dotted, and this is less than. Again, it's in slope-intercept form. Now, where do they overlap? Well, they don't. This one's going up, this one's going down. They're parallel lines, so they will never intersect. So this one is no solution. Now, with inequalities, though, just because they're parallel doesn't mean that it's going to be no solution. Okay? I should be able to tell here that they're parallel because these slopes are the same. But just because they're parallel doesn't mean that it's no solution. If this one would have been shaded up and this one would have been shaded down, then the part that they would overlap would be between the two, and that would be the solution for those. Okay, so for this one, there's 3 lines, and it's very similar. It's the same thing. You just got to do all 3 and pay attention where all 3 overlap. I'm going to show you a little bit of a shortcut that I like to use so it doesn't get messy, but you can still do it the same way we have been. I start out the same way. Let's go ahead and graph all of them. For this first one, I got to divide by 2. So I have y is greater than or equal to 3 over 2x plus 1. M is 3 over 2, b is 1. So I plot my y-intercept, rise 3, run to the right 2, rise 3, run to the right 2, and I'm going to keep going until I run out of room. And I'm going to go the other way too and then get my ruler. Pay attention to whether it's dotted or solid. This one is solid. I'll go ahead and look at the part that's shaded. And what I like to do here, it's in slope-intercept form. It's greater than, so it's shading up. So what I'm going to do is I'm going to put an arrow on both ends of the graph where it's shaded. So I kind of use a different color for that so you can see. And now I'm going to go ahead and do the next graph. Well, I already have it in slope-intercept form. My M is -1. My B is +6. So I'm going to graph that at +6. Use my slope, down 1, left 1, down 1, left 1, and so forth. And again, pay attention. This one is dotted. Draw the arrows. And from this one, I'm shading, it's less than, so I'm shading down. So I'm shading this way. So far, if you've seen the shaded region where they overlap is down from this blue one, up from this purple one, so it would be this section here. And my last one I have to solve a little bit, and I'm going to subtract 7x. Divide by 2. I'm going to write it up here at the top so you can see it. Y is greater than or equal to -7 over 2x plus 1. So my y-intercept is 1. Down 1, 2, 3, 4, 5, 6, 7 over 2 to the right. That's a negative slope. And go the other way. Up 1, 2, 3, 4, 5, 6, 7 over 2. And draw my line. I'm going to get my ruler. Pay attention, is dotted or solid? This one is solid. And put the arrows. And from this one, it's shaded up. So it's basically, remember, it was this whole section here, but also up from the green one. So the only part that should be shaded is inside this triangle here. And the vertices of the triangle that it makes, this one is -2, 8. I have the point 0, 1, and this point is 2, +3. And those are the 3 vertices for that point, or for the triangle that those 3 lines created. So here are some U-try problems. Pay attention to whether it should be shaded or not. Like this first one is just equal signs. So that's just like the first one we did in the notes. Where they intersect, that's your solution. It's only 1 point. It's not the shaded region. Once you get to the inequalities, now they're shaded. Pay attention that this one is an absolute value. I didn't do one like that. Go ahead and try it. We'll talk about it. It's the same thing though. And then this has... So I'm going ahead and canceling off this you try problem. So just do the other two. And these are the answers of what it should be. For this was number 2 and this was number 3. And if you have questions, we can talk about it in class. So here's a joke for you. What do you get when you cross a cow with an earthquake? Milkshakes!